Okay, here is the basic wiring for the physical button connection. So keep in mind, you need to have the green wire there is in the ground and the yellow wire is into the 3.3 volt output from the board. The way I know that is I look at this chart, and over here, this chart actually tells me the different pins. So I can see that pin number 38 there is G and D, which is ground, and pin number 36 is 3.3 volts output. So that's just power. There's 3 volts coming out, and this one is ground. So I've gone ahead and I've gotten those wires right there. And notice I just pulled them out and I hopped them over. Because the pins from this board are in these little 5-pin rows, so one of the pin row 5 and row 3 on the breadboard, the rows in the middle are connected. All 5 of these pins are connected acrossways, so that if you plug into one of them, it'll connect to all other 5 pins in each row. So that makes it easy to prototype electronics. But because this is power and ground, and circuits always want to run from power to ground, I went ahead and I used the yellow wire here to hop over to the power column on the side of the breadboard. That's an easy way to prototype, because now by bringing this over, it makes this whole column, the plus red column, a positive source of electricity all the way down. The column on the side runs all the way down connected. So there's positive power all the way down this side of the breadboard. Similarly, there's now a ground connected all the way down this column. Only the columns work like that. The rows in the middle are connected horizontally. So that allows me to plug in my wires and things down here out of the way, where I don't have so much in the way with my fingers. So then I hopped the power over to row 30. I got one of these little buttons out of the bag. See the button there? And I pushed it down. I put it into the slot there at 30. I put the other leg is actually in row 32. I got a 10,000K resistor. So a 10,000 ohm resistor, a 10K resistor. And I bent the legs a little bit and I pushed. Notice one leg is in the same row as the other leg of the button, because the button hops the electrical signal. And the next thing I did here is I got my LED. And one thing I want to show you about LEDs is that LEDs have a long leg and a short leg. The long leg needs to be the positive feed side of the circuit, and the short leg needs to be the ground. So when I get an LED, let's get one out of the bag. If I get a fresh LED, go ahead and pour a few out, you'll see that these LEDs, they have long legs and short legs. See that? And so when I'm preparing to do some electronic work with one of these, I will intentionally take the long leg and I will bend it out, and then I will bend it a little bit straight. And now I know the long leg because it's kind of bent out, and that's my positive. That needs to be my positive. So I already bent this one, and I want my positive to feed off of the resistor. So I'm connecting up a circuit. A circuit is literally has to be connected all the way through to the ground. So I'm going to plug it in, back in there, and I can verify that it's plugged into the same row. These rows could be any rows. I just happen to have used the ones I'm using. So that's number 38. And then the other leg of the LED, the light emitting diode, is in row 40. And so I am now connecting up the final piece, which is my green wire, to the ground. So that's how the electricity flows. I've got a switch here. This is a manual circuit, so it allows me to just test up the basics and know that the power is running to my Pico and that I'm using a manual circuit. Next, we'll make a digital circuit.